Hey everyone, here's 9.4. We're going to talk about some trig ratios, specifically the one today called tangent. And a trig ratio is just a ratio of two specific sides of a right triangle. And we are going to have special names for those ratios. So if we're looking at a right triangle really quick, so here's my right triangle. And let's say I'm talking about angle A here. I have my hypotenuse, and in a right triangle, the side opposite the angle I'm looking at is called my opposite. And then the side touching it that is not the hypotenuse is my adjacent. So with all your trig ratios, you are going to look at some type of combination of adjacent, opposite, and the hypotenuse, any two of those three, and they have special names. So today we're going to focus on the special name called tangent. The tangent of an angle is just the ratio that includes the opposite side divided by the adjacent side. Something else you need to know is, let's say I'm shooting a water balloon from a water balloon launcher off the ground. So here's my ground. And then I have this type of angle that I'm launching it at. That angle of elevation is that angle that I'm showing you right there. Okay, so the whole thing I told you about tangent, that's what this bottom part says. So let's just go over here to some examples. I might not do all of them today. Let's just do a couple. Let's look at example one. It wants me to find the tangents of the acute angles. That'd be angle R and T. So if I want to find the tangent of angle R, I need to know its opposite and its adjacent. So remember, tangent is equal to the opposite over the adjacent. We shortcut that to memorize it as TOA. All right, we'll do the other two trig functions in the next lesson. So the opposite side from R is 45. That's my opposite. And my adjacent is the 24. Now, we want to simplify these fractions. So 45 over 24 is the same thing as 8 over 15. Now, this does ask you to put this in the calculator and round it to 4 decimal places, which I'm not going to do right now. And then we can do the other one. Let's talk about tangent S. So the tangent of angle S, its opposite is going to be the 24. Its adjacent is the 45, and we simplify that. We get 15 over 8. So that's the gist of this. The only thing you have to realize is when you get to question like number 3, and I'll just do one of these. Let's say I want to find the tangent of C. So tangent of C, its opposite is square root of 2, and its adjacent is 2. That's good because it's just done. It's just square root of 2 over 2. But if I look at the tangent of A, I'm going to have the opposite, which is 2. Its adjacent is square root of 2, and then I have to rationalize that denominator. To do so, I multiply both sides of that fraction by the square root of 2, which gives me 2 square roots of 2 over 2. The 2's cancel, so I just get square root of 2. So that's the tangent of A is just the square root of 2. All right, so that gets us through that part. And then we get to actually solving parts of triangles. So because every triangle that's a right triangle that also has a 10-degree angle, so if we have a 90-degree angle in both triangles and a 10-degree angle, due to the angle-angle theorem, they will be similar triangles. And we know similar triangles that the corresponding side lengths are proportional. That ratio is. So with that being said, I can look at a special ratio called a tangent, and that just means I'm looking at the opposite over the adjacent. So if I look at angle 10, my opposite is 5. So the tangent of any 10-degree angle is going to be equal to, so that ratio is going to be equal to its opposite divided by the adjacent. Sorry, the opposite here would be 5. The adjacent is x. So I get to solve for this. So if you go old school algebra, multiply both sides by x, I'm going to get x times the tangent of 10 equals 5. Divide by that tangent of 10, I'm going to get x equals 5 divided by the tangent of 10. A little shortcut, when x is in the denominator, just swap the two. It works. This is what you're going to put in the calculator. Now, the problem with the calculator is you have to go to the mode. So go to mode in your calculator and make sure you are in what's called degrees. not radians. It has to be in degrees because we're talking about an angle measurement, which is 10 degrees. I put this in the calculator. I round to 1 decimal place, and I'll get 28.4. All right, we're going to do just one more. We're going to do number 5. And why I'm going to do number 5, because if I talk about my tangent of 64, that's equal to its opposite, which is x, and its adjacent is 13. To solve this one, I'm going to multiply both sides by 13. And now I just have to put this part, 13 times tangent 64, in the calculator. When I do that, I get x equals 26.7. All right, I'm going to skip, let's see, let's go number 7 really quick. So number 7, we have a triangle. I'm actually going to draw this, boom, boom, boom. And E is the 90 degrees. So then I have C and D. And it says if tangent C is 4/3, so that means I'm going to have tangent is opposite over adjacent. So if I'm looking at C, my opposite is here, which is ED. So I have 4. My adjacent is 3. It says find the tangent of D. It just so happens D, my opposite is 3, and its adjacent is 4. And what this problem is trying to show you is that the tangent of one acute angle is going to be equal to the reciprocal of the other acute angle's tangent. But drawing a picture helps. The only thing left, I'm just going to get this set up, is going to be no problem. There we go. So we're going to skip, I'm going to go ahead and skip these two really quick, number 8A and B. And let's go ahead and just set up number 9. The setup here is you have a boy who's flying a kite, and there's an angle of elevation of the string of this. It says 18 degrees, and that's based off the ground. Now the kite reaches a maximum height 300 feet away. So that is going to, so here's my kite. All right. My height is 300 feet away. And we want to know what is the height of the kite, which is going to be the h here. So I have opposite and adjacent. So I can say tangent 18 equals opposite, which is 8, over adjacent, which is 300. Multiply both sides by 300, round to the nearest tenth, and I get it. The height is about 97.5 feet. There we go. Now, what's going to happen on number 10? This is quite a bit of a complicated, not really complicated, but just quite a bit of a lengthy problem here. Give it that 300. Is to find the perimeter. The perimeter means we need to find the following. We need to find all this that's highlighted in yellow. Now, the only thing that I know for sure is just some angle measurements on one side. So what I can do here is I can find this angle here. Sorry, this angle of 33 degrees. I can find this side because it's my adjacent and 8 is the opposite. So I can say tangent 33 equals opposite over adjacent, which would be sort of like an x. So when I solve for this, I get x is roughly 12.3. So I can put that up here, 12.3. Now, where do I go from here? If I trace this larger triangle really quick, I have 2 of the 3 sides. I can find the missing side by saying 12.3 squared plus 8 squared equals my hypotenuse squared. So when I solve my Pythagorean theorem, I'm going to just really do a shortcut here. I'm going to get that C equals 14.7. But notice what I had here is I had these congruent marks. If the whole thing's 14.7, I could cut that 14.7 in half. So cut 14.7 in half, and I get that that is 7.4 if I round to 1 decimal place. So this is 7.4. That's 1/2 of it. Well, now what I can do is I can just do another trig function. So I can say tangent 64 equals opposite, which is I don't know, over 7.4. And then from there, I can figure out the opposite side. All right, there's the notes, and we'll see you in the next lesson.